All right. Good morning, everyone. So let's just get going here. So I'm going to start with talk about the optional type. This has nothing to do directly with streams, but you have to know it in order to use the library. So as you know, in Java, it's a very common idiom to use the null reference whenever you want to indicate that some method was unable to find some result. So if you have some old-fashioned method here, get some search parameters, and it returns a result, then it is common to get null if there is none. Now that's of course a problem, because when a user doesn't think of that case, then at runtime the user might invoke methods on null, and then you get a null pointer exception. So the problem is that it's a runtime error, and so it can only be found through testing. What would be nicer is if there was some compile time check that made sure that the user of this method was at least thinking about the fact that this thing might have been null. So in Java, there's no difference between a string that might be null or a string that's definitely not null in the type system. There's some languages that make such a difference, but Java just doesn't. So a library class has been created to overcome that, called optional. And so the stream library uses this, and it's also a good idea for you to use it whenever you write any method that might or might not return a result. So optional is kind of similar to null, but it's an object of this class. So as an example, we want to find the first string that's longer than 10 in a stream of strings. So we filter and retain only the longer ones, and then we call find first. Now, find first, you would think, then returns a string, but actually find first realizes that the stuff that it works on, this stream over here, might be empty. Now you might say, why would a stream ever be empty? But when you filter, this really happens, right? You filter to find something, and if there was no match, then the stream is naturally empty. So find first has to be able to deal with that situation. Now, of course, it could have been written to return a null. But number one, what if the stream itself contained nulls? Then it would be difficult to distinguish the nulls that were in the stream from the null that means there is no match. And also, you have the fact that if the user didn't pay attention to it, then the null is unsafe. So for that reason, you get an optional of string, and then you have to learn how to work with that. So you get that for any operations where there might not be a result and where there's no natural default. There's as you will see later when you compute the sum of a stream of numbers, even if the stream is empty, you get 0 because that's a reasonable default. But for find first, there is no reasonable default, so you have to work with an optional. So the hardest thing for people to get used to when working with an optional is that they treat it just as if it was a potentially null value. And so that's not so good. So here's what you're supposed to do. You're supposed to use one of these two methods if you can, or else, or if present. So or else is the one that's almost always the simplest one. So if you have an optional, it usually happens that there is some reasonable default that you know makes sense in this case, even though the library wouldn't. For example, if you just want to know what was the length of whatever this string, that then you could say, well, if there was none, I'll just measure the empty string. So this way, if you wanted to find out what is the length of the first string that was longer than 10, then you would get for length either 0, which means there was none, and at this point you know the logic well enough that that 0 is meaningful for you, or you would get the actual length if there was one. So or else works in the grand majority of cases, because usually that is a default. So how it works is of course straightforward. So the or else method either returns the thing that is wrapped in the optional, or if the optional happens to be empty, then it returns the thing that you nominated here. The other thing that that sometimes works is if in the case that the optional was empty, you just simply want to do nothing, which is also a common case, then you can use if present. If present takes an action, and So that the action has a parameter, namely the thing that was wrapped into the result, and then you do whatever you want to do. In this case, maybe I wanted to collect the results. So this action probably has some side effect. Here it would have the side effect to add it to some collection. So if neither of those two works, and once in a while you are in a situation where neither of those two works, then you use is present, which is pretty much like testing whether something is null. And if the thing is present and you need to get it out, then you can call get. And otherwise, then you do something else. So is present and get work exactly like the not equal null test. And if you call get without using is present, then it's just the same as if you were using a value without checking it against null. If you were unlucky and result was empty, then you get an exception. So let's see if everyone got that here. So I give you 4 alternatives for searching for the first string that contains an E. And so I want to know which of those do you think is the best? So if any of you forgot to bring your voting cards, I have more. Does anyone else need a set?
Oui. Je crois que tu t'es fait passer. T'as des B, toi? J'ai changé. Au pire, est-ce que tu peux t'écrire B sur ta carte? Enfin, je vais...
All right, does everyone have a complete set of cards, or at least the card of what you want to vote for? So how about you show me your vote? Are you not ready? Okay, show me your votes. B, C, B, D, D, A, D. Oh, this is good. You guys have no opinion? Undecided between A and B? And you don't have cards? Okay, go. Oh, I see. So you can vote. All right, so let's eliminate some that are probably not very good choices here. So I don't think A is a good choice. Why not? There's an E in the word none, right? So you have a question?
Doesn't it very much, which one is the best answer, doesn't it very much depend on what we're planning on doing with it after?
Yes. Next question. So it very much depends on what we want to do after. And so when I ask, what is the best thing, you have to use your professional judgment in the answer. So it's not like an exam question, it's like an interview question. But yeah, that's exactly the point, right? So, but that's why I first want to eliminate the ones that are almost certainly bad. So I think this one is bad because, what if the word none was there? I also think this one here, one can eliminate as bad. Because now we've gone through all of this trouble with optional just to get back to the situation that we had before that we wanted to avoid in the first place, namely the danger of the lurking null. So I think A and C are not so great. Now, to differentiate between B and D, you really need to know the context, right? It may be that B is just fine. It may be that the code that receives this thing is perfectly well prepared to deal with the fact that if there was no answer, the empty string is good. Because after all, the empty string couldn't possibly have contained an E, so one could carry on the logic. But in absence of anything else, I would vote for D, because D is always going to be a good answer. Right? Then it's up to the user of the thing to deal with the optional in whatever way that they want to deal with it later. So in absence of any context, I think D is a good answer. But if you said B because it's clear what to then do with it, it's fine too. So these questions are not there just to say whether you are right or wrong, but to make you think about this stuff. And so maybe it's succeeding.
Find first returns a string or an option?
It returns an option, as you can see from here. So it returns an optional string.
Oh.
Always. Well, it can't sometimes, right? It has to have a definite return type. Yeah, so find first, max, min, all those methods return an optional because the collection that they were working on might be empty. So what if we want to do the same thing in our functions? So here I'm writing a function square root, and I want to either return the actual square root if x was positive, or I want to return an indication that there is no answer if x was if x was negative. So it's very simple. There are two helper methods, optional.of, and it takes the argument that you want to wrap. That gives you an optional that has stuff inside, the good case, or optional.empty gives you an optional value that represents no solution. So notice that this off works exactly like streams.off, or stream.off, except you only put in one element because an optional can contain at most one thing. And I guess they could have called this one optional.off with nothing inside, but for clarity they use optional.empty. So you could think of it as an optional as something that either has 0 or 1 element in it. And that's all you need to do. So give it a try. So here I give you a potentially useful method that computes both the min and the max of a collection at the same time. Because if you think about it, when you traverse a collection to find the minimum, it's no trouble to also find the maximum at the same time. You're already traversing it. So then I'm putting it into a pair. This one here, I am returning the pair of the minimum to maximum. And you can see that I'm assuming that this collection has at least one element because I'm taking the first element as the first candidate for the minimum and the maximum. So what I want you to do is change it so that it takes care of the situation where the collection might be empty. In case you're a little rusty with iterators, the hasNext method tells you whether an iterator has a next element coming, whether it's safe to take next.
Yes, we just put back overloading just as a concept, not a existence. Since I was because since we only deal with integers and doubles, we don't have the tricks with the integrals and bytes and
I don't know what makes them bring all these things back.
I think it's fun for them to
Yeah, that's the fear, right?
Yeah.
Yeah, I understand. Obviously,
Yeah.
I think clearly it does not greatly increase the expressiveness of the language.
I had a just within this time, a discussion about new operations.
Yeah.
Yeah,
Yeah,
are you aware of this?
More or less, yeah.
Because myself I've been using you are more than software.
Well, so that's actually useful to know because that would make them stop worrying so much about the I mean, the only rational reason to care about cross references is one is that you're worried about when you copy a vector in or out of the function by value, and you say, well, gosh, it's too expensive, but it actually is good.
Because of this.
Yeah. Yeah, so maybe I need to explain that. I don't think that I'm going to give up there. I think I'm going to cross references, this is the lost one. But more importantly is
Case where cross-reference are used when you have a function of
we can always replace the cross reference, and assuming that you don't mutate your parameters, which is a good handle.
for instance, you have a reference on a function. A function that takes a reference in the code. Then you cannot pass it or
But that's fine. But why would you want? The only reason you use a reference is because you want to actually mutate.
Yeah.
Right? There's never a reason why constant value. You could just pass by value. You should just pass by value. You should just say we pass by value unless we want to mutate. And
That's my point too.
and so the constant reference is just an optimization.
Yes.
So I don't. That's let them fight about something. As long as the grand scheme of itself.
Yeah.
Yeah. Really didn't like the editor less.
Yeah.
So he's not there. So the program will still use the thing there. Just have to validate the URL
Yeah.
check out that it's
Okay.
and then you submit and you have the thing.
I want to see that.
So I just did the exercise with
Okay, so okay.
but I have no idea of the script. It's just
Okay, yeah, send me the URL. I want to see it. See, that's something that is on my list of things to do. In fact, I have a graduate students. This guy might have done his job. All right, so let's have a look at this. So in this case, we have to do a couple of things. For one, I have to make sure this returns an optional. In the good case, I have to return optional of. So in this case, I have optional of, and then I have pair of as it happens, but that's fine. And in the bad case, we'll have to first find what the bad case is. That would be the case here if this iterator, if it doesn't have a next. Then I just say there's no max and no min, and that should do it. Okay, so just as an aside here, these factory methods with name of are quite nifty. If you look at the pair class up here, it also has one of them. So it's pair.of. And so you might say, why use pair.of when instead you could just make a new pair with the constructor? But pair.of has a great advantage, namely that it does type inference. So when you say over here I say pair.of min max, I don't have to say what the type of the pair is. But when I say new pair, then I have to say new pair of t. And so just in general, you get free type inference for methods, whereas you don't get free type inference for classes or for constructors. And so that's one rationale that when you use generic code, that you really prefer factory methods over constructors.
Question.
Yeah.
How do we avoid when a tree has next at the first iteration?
I'm sorry?
Yeah, one you test has next for the first one.
Yes?
Then again for the second one for your min, and then again I use the right.
So I have a test here and another test here.
Yeah, but just for the iter is what next on the min. Is there a way to avoid this tree?
I didn't get it.
Yeah, one here and next.
Yeah?
For the first one.
Oh, you what? So you want to put it all in one loop? I don't see how to easily. I could use a do while loop, I guess.
Yeah, but I was wondering if you can.
I think this is life because you have to prime min and max with something.
Why do we use iterator dot has next and elements dot is empty?
Oh, you could do that too. You could do that too, but that would require that you know about that method. Whereas the iter has next is right here, so I figure everyone can read that. But that was there's no great. And it's a good question how the empty is implemented. And for all you know, it takes an iterator and checks whether it has next. So generally, when you look at how these default methods are implemented, they tend to be implemented in terms of iterators because that's all we have. All right, on to... So there's another operation called find any, and find any is just like find first, except it gives you any old answer. You might say, what's the rationale for that? It's only beneficial for parallel streams. We'll talk about parallel streams next Thursday in more detail, and we'll do some performance measurements. And in that case, the rule of thumb is use find any when you have a parallel stream. If you use a linear stream, you might as well use find first. Yes, there's one other advantage of find any. Two fewer letters. All right, max min are common operations, and they return an optional for the simple reason that you might be working on an empty collection. And this, and also with max and min, you can pass a comparator in the normal way. There's a couple of potentially useful operations that check whether a predicate is fulfilled for all elements of a stream, for any one, or for none. And so if you wanted to find out whether all words in a collection contain an E, then this is how you do it. And they're easy enough. We'll use it once or twice. So now we get into an unhappy aspect of this whole stream stuff, and that's always going to be the case in Java until they get around to fixing this nasty issue of primitive types. So if you remember back in the days when Java was first invented, the decision was made, which sounded harmless enough at the time, that the number types int, short, long, and so on, and float and double, the character type char, and the Boolean type, that those would not be objects. Those would be primitive types. They would be just passed by value, whereas objects are always used through a reference. And so you have this fundamental dichotomy in the type system. They did that, of course, for a reason of efficiency. They felt at the time that it would be inefficient to represent integers through objects, boxing them up in a separate object. And of course, that's true. And the people who had been doing this kind of stuff for years, like the Smalltalk people, for example, were a little puzzled by that because, of course, what a decent virtual machine will do is they will optimize this stuff out. They will say, sure, it says it's an object, but we're internally just going to represent it as a single value. And so the Smalltalk virtual machine had done this kind of stuff for years. So why didn't the Java people do that? You have to remember that in 1995, the Java virtual machine had the computational power of a toaster oven, and so it simply was unable to do this kind of optimization in a case that happened very frequently. A few years later, the virtual machines got much better. And at the time, people said, gosh, we really need to deal with this. We should just go back to change the definition of the language and say int and integer are just the same thing. But it was too late. And there's two reasons. One is that it's hard to deal with this stuff with arrays. To find, then an array of ints has to be the same thing as an array of integer, and they got into nasty cases with that. And the other one is that there were some people out there who used, so when you want to change integers to int, then you have to say if you have like a new integer of 4 and you have another new integer of 4, they should be undistinguishable. One should be able to map them both into just the number 4. But there were some idiots out there who used like a new integer of 0 as a lock, and then another new integer of 0 as another lock. And so if one were to convert those two into 1, then the locking code wouldn't work. Now, what would possess anyone to use new integer of 0 as a lock? Boggles the mind. But
You can use a new object.
they could have used new object, exactly, or or something better for locking, whatever. And because Java prides itself in being totally and absolutely backwards compatible, they gave up on it, and then it wasn't discussed again. Right now, actually, the same people who gave us streams are engaged in a heroic effort to try this again. It may happen that in Java 10 or 11 that they will finally get this straight. That would be really wonderful, because the library totally suffers from this, that when that you always have to have special cases for primitive types. And I think streams is the first time that they really, really noticed just how bad it is. So for collections, you're saying, how often does it happen that you have a list of integers? It's not really that big a deal. For those few cases, you can just use an array. But with streams, where you have a rich API, and you want it to be efficient with numbers, it's become quite bad. So consider a case where you have a bunch of numbers, and for whatever reason you want to square them all. In real life, you would do other computations. Now, because the thing stores integer objects, it means that to do this computation, the integer has to be unboxed, and then the result has to be boxed again. And so that's completely unnecessary, and it's not possible to optimize it away in the virtual machine, or not easily possible at any rate. So what they do is they give us an int stream. So an int stream will, we never know how the internal storage of these things work, and in fact, there is no internal storage because it has to be done elsewhere. But first of all, an int stream can be efficiently backed by an array of int, as opposed to an array of integer wrappers. And also, more importantly, whenever you apply any methods, those methods can have parameters of type int. Because a lambda expression can perfectly well have a parameter of type int. It doesn't have to have a parameter of type integer. So with lambda expressions, all types, objects and primitive types are supported. The only time where you have the restriction is with generics, that the generic type, because of type erasure, cannot be primitive. So so they give us int stream, double stream. Oops, and this is a typo here. It should be long stream. And double stream. Well, they should probably also have given us the other 5 primitive types, right? Short stream and byte stream and char stream. But they say that's ridiculous. So they give us these 3. Boolean stream, exactly, right? So clearly that's too much. And so they've given us these 3 and said if you need to use the others, you could always use an int stream if you wanted to have a stream of trues or false, and just use zeros and ones. So you would want to use these for 2 reasons. One is because you're concerned about efficiency, and the other, as you'll see shortly, there are a few nice methods such as sum and average that obviously require numbers, and they are then supported on these numeric streams. So let's see the efficiency angle a little bit. So consider this code here. So I'm having an infinite stream of integer values. I only take the first 1,000. I only take the even ones, and I multiply those by 2 for whatever reason. And then I want to count them. I have no idea why I want to count them. I just do. And so my question is, how many boxing and unboxing operations are necessary for this computation? So how many elements do we have in the stream at this point? 500 elements, right? At this point, how many elements did we have to consider? 1,000, right? And so that means how many times was this code here called? How many times was the generator called? Also 1,000 times, right? There would be no need to call it more than that because it goes backwards. So how many boxing operations are needed for each of those? So figure that out and you'll have the answer. Okay, let's come to a vote. Yes, now. So we have a bunch of C's, D's, B's, C's, C's. So the majority vote seems C, and there's a whole bunch of D's. And so let me do my computation. Then if I'm wrong, then D will have been my escape hatch. So what I thought was going to happen is the top operation, where 1,000 values are computed, it has to do unboxing of the previous value and then boxing again of the next one. So this has to be multiplied by 2. The filter here, it needs to unbox the value that it gets, but it doesn't need to box the result back in, so that's 1,000. And 500 times, one needs to unbox the n and then multiply it by 2, so this would be times 2, and so the result would be C. Now, those of you who said D, did that make do something wrong? Or what made you think that? So I think you said D, right? No? Who said D? Someone own up to it. I just want to know what one might have been thinking here. Yeah?
I haven't considered it as
Okay. That's fair. All right, so the whole point of this is that with innocent looking code like that, there is a large amount of boxing and unboxing going on. And so that's the motivation to deal with primitive type streams. So now we have to learn a little bit about them, how to make them, what one can do with them. So just like with a regular stream, you can use .of. So, and it also works with arrays. So if you have some small number of values, or if you have potentially large array, you feed it to .of, and you get, in this case, an int stream or a double stream or a long stream, depending on which one you want. A very useful one is intstream.range. That gives you all of the numbers between A inclusive and B exclusive as a stream. And one uses that a lot, and you'll see some applications soon. Another useful thing is if you have a random number generator and you call ints on it, and you give it a low bound and an exclusive upper bound, then you get an infinite stream of random numbers. So here I get an infinite stream of die tosses, and I couldn't, if I wanted to have 10,000 die tosses, I would just limit that to 10,000. And that's the fastest way to get yourself an array of random numbers. Another really useful method is when you have a string and you want to get the code points of that string, then you call .code points. So you have to know, to understand why this is so useful, I probably have to give a quick refresher on strings in Java. So when you have a string like this, it's a Unicode string, and so we kind of have this idea that the length of the string is 4 because there's 4 car values on it. But now look at a string that contains a number. So my favorite example is that in a math book you might find O is the set of octonions. And so you have the mathematical letter O.
Now you have to explain what's already set of octonions.
Yes, I will gladly, after class, explain to anyone who wants to know what the octonions are, if I can remember from my days as a grad student. They're just like the quaternions, but worse. So why do I use O? Because as it happens, O uses 2 car values. So it's a letter that is not encoded as a single car, but as 2 16-bit values in a row in the encoding that's used inside the virtual machine. Now this should have never happened. The whole idea of Unicode was so that every character known to man, past, present, and future, could be encoded as a single car value. And that worked fine in 1995. So what had happened, Unicode was it had just been invented. The people who did the standardization asked everyone, how many characters do you need to encode your language? And so they asked the Japanese and the Chinese and the Koreans, who had the most of them, and each of them said 20,000 or so. And there was a bunch of overlap, and so they checked that all of those languages, together with all the Western languages and the Indic languages, which are alphabetic and then not that many. And so they said, we can comfortably fit everything in 65,000 characters. Then they asked the Chinese, are you sure? And the Chinese, yeah, totally sure. We've done this for years. We know what we're doing. A year later or so, the Chinese came back and said, by the way, we overlooked those 40,000 rarely used characters, some of which are the names of people, of which there are 100 million or so. Because it's a large country. And so then it became apparent that a 16-bit code was not long enough. And unfortunately, Java had been born between those 2 points in time. So Java was born at the time when people earnestly believed that a 16-bit code was enough, and then later Unicode expanded to now it is 21 bits. And so it's encoded in 16 bits, but some of the characters have two car values. So one calls a thing like this here, it's a code point, and for that matter are all these things. This word here has 4 code points. This word has whatever many code points. But some code points can be encoded in a single car. Some code points are encoded in more than one car. For Western languages, this situation does not yet happen very often, except there's one important block of commonly used things, or more commonly used things that use 2 cars per code point, namely the emoticons. And so if you process any text that contains more than just the smiley face, but nowadays they have the head-scratching frog with 2 livers, and so all of those they use 2 car values. They're standardized, and people do want to work with them, and so it's becoming more important to understand this difference. So unfortunately, the Java library there is an API that lets you iterate through the code points of a string, but it was designed by someone like my younger brother, earnest but muddle-headed, and so it's essentially useful. And so when streams came up, some helpful soul said, oh, this is our chance. And so they gave this code points method, and it works great. It gives you the code points of everything in the string as an integer as a maximum 21-bit integer. And so now you no longer have to use cars. So in fact, at this point, if you ever use the type car, you're probably doing it wrong. There's no great reason to ever use car to analyze a string. Every time that you want to analyze a string, you should probably use this method. That's the only method in the Java API that easily and truthfully tells you what a string is composed of, what code points it's composed of, because that's really the only thing you care about. You don't care how it happens to be encoded in UTF-16. All right, and we'll have an exercise to make use of that. So now the other thing is mapping. So when you call map, and now you give it a function that consumes integers and produces integers, such as here, I have just an example here, then that function can be applied to an int stream efficiently. There's no boxing and unboxing. There's nothing different about the API. You just have to you just realize that when you use map, you now should feed it a function that consumes and produces these numbers. To make really sure that you understand the importance of efficiency, though, they made it so that if you want to map to some other type, you have to say map to obj. So in this case, you have a method that consumes an int, not an integer, but an int, that consumes an int, and that produces an object. In this case, the object is a string. The reason they do that is, if by accident you had something that returned an integer and not an int, that you would get a compile time error right then and there if you didn't use map to obj. So map to obj says, I want this thing as an object. And then there's map to double, map to long. Again, this could have been type inferred, but they want to make sure that you understand the cost implementation. So one other interesting thing about this particular example, so here I have an example where I take the string Mississippi, I take n as the length of the string, and then I do something that's actually kind of interesting. I take this int stream, that's all the numbers from 0 to n exclusive, and I call map to obj, or I could call map if that's what I wanted, but in this case I do need objects. And I say map the ith thing to the substring, and then I get all the substrings of the string. I get a stream of all of the substrings, of the initial segments, I should say. And then I can do something with that, whatever. So in other words, I've just written a loop that generates these initial segments, except I haven't written it as a loop. And so it's a trick of the trade that if you need to loop through something where I goes from 0 to n, that the thoroughly modern way of doing it that is to use instream.range and then map. So anything where you need to generate stuff that depends on a parameter that goes from 0 to n, this thing is your friend. So it's the stream equivalent of a loop. Now every once in a while it happens that you have a stream of numbers and you need to turn it into a stream of objects. We'll have a case in one of the exercises. And when you use box, then that'll box all of the elements in there. And I can't even remember right now why it happens, but the compiler will remind you when you need it. So now I want you to try this out. So here I have a stream of strings, and I want you to give me back the distinct lengths in increasing order that you find in there, paying attention to efficiency. Into colon. Okay, now the internet died for me.
It's saying that it's not the
Okay, thanks.
So I think I might have to.
Non, je ne trouve pas ici. Mais bon, moi je suis mauvais, donc on peut écouter ce que je dis.
No, no, because it keeps the hash tag, the hash string. You have to. Yeah, it's impossible. It's impossible that the strings hash there, hash out.
Non, c'est A, en parenthèse A, virgule B.
And I can't imagine
Flèche A, plus grand.
All right, so
Avec A moins B.
so we call map to int. So map to int is the one that gives us the int stream, and we give it some function here. Pat yourself on the back if you use string : length as the method expression, but you could say x gets mapped to x.length. We have to it wants them sorted. Take out the duplicates, we have to sort, and then we're good. The code check setup actually checks that you do it in this order. If you first sort, then it says that's not the most efficient way, because when you think about it, that you have a pretty large set of integers, and the cost of sorting that large set, is certainly goes up. Whereas distinct is fairly cheap, so it's a linear. It grows linearly. So generally, if you need to sort, it's slightly cheaper to first throw out the duplicates. And that's the answer, right? Notice to array. What's good about to array? There's no nasty new parameter. I didn't have to say int : new. In fact, it wouldn't work with that. So toArray knows that the answer has to be an integer array because it was an int stream. Generally, I hate using toArray with streams because I can't get myself to type the type name : new, and I always use lists then, collectors to list. But with primitive type streams, they work the right way. So that's another slight advantage of primitive type streams, that the parameters and return types for them have generally been optimized so that you don't have to worry about about the generic. So toArray returns an int array, no constructor expression required, and there's a couple of other places where it's slightly simpler. More importantly, you get 4 nifty methods, sum, average, max, and min, that work out of the box and give you what you think they are. And so if you wanted to compute like the average word length, then you would do it like this. You would map the words to an integer, compute the average, and you're done. That's a very fast way of computing the average of anything. In fact, if you have an array of int, if somewhere you have an array of integers lying around, the easiest way to find the sum of them is to say stream of v's.sum. That's the fast, in terms of number of keystrokes, that's the shortest way of summing it up. And it's not particularly inefficient. So all of the stuff that they taught you in Inf 1 about writing a loop, that was there. So all right, so that's what I have about the textual material. So now I have a number of exciting exercises. The first one is kind of cool. And so this again uses this pair class. And now I want you to write like a method that turns a pair of integers into a string that has the form, for example, 3, 4, no spaces. Except if it was if the pair didn't exist, I want you to do 2 brackets with no spaces. And the challenge is when you get the optional, so over here you're going to have to change this thing here to an optional. And now the optional either is empty or it's not empty, that I don't want you to use get. So go ahead and try that. So I've seen some of you furiously going through the API. So if you don't use get, what are you going to use? And the obvious solution would be to use to do this. So first of all, we'll make this into an optional. Say if a pair is present, otherwise return the empty string. Right, that would work. Except evil code check says do not use get. It's a perfectly correct solution, but I want you to figure out how to do it without get. Why do I want you to figure out how to do it without get? So that you furiously look through the API and figure out what else you can do. So what else can you do? If get is verboten.
We can use the or else methods.
So let's try with or else, right? So somewhere we want to use return something 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 pair or else. Or else what? Something something something. What is the type of the or else thing here? No, it has to be a pair. In the one where you're looking at, it was a string because that was an optional string. So or else has the nasty property that whatever the else is, it has to be the same type because a method has to have a definite return type. So the return type of or else is t for an optional of t. If you have an optional of pair, it returns a pair. So you would not have to give back a pair. And I guess you could do something ugly by having either give back a null and then resolve the null later, or give, God forbid, a pair of null, a null, and deal with that. But that's not so pretty. What else could you do other than or else? This is a perfect example that one learns exactly nothing from the lecture, right? Because I went through this at great detail, and I said there's 3 things you can do. You should try or else, and if that doesn't work, you should try if present, and if that doesn't work, then there's get, except get is now blocked for us. So what should we try? Well, this slide tells us we should try if present, right? So pair.if present. If present takes an action, a function that gives that should do something. What could it do? So we want to take some action if the thing is present. So we have to have something where we're setting up some object, where if it's present, then we change it in some way, and then we after that then we return the thing, which either was the unchanged object if it wasn't present, or it was the changed object, depending on what change we are. So what could you do in order to build up the value and then edit it? So the trouble is you can't say string r equals, but this would actually be a good try. So let's say we set a string. Let me do it in fact in the code, and then you'll see why I can't do it. So a reasonable attempt would be this. String r is double quotes. If pair is present, no, sorry, pair if present. Pair if present. Then we get the pair that is present as P. And in that case, I would overwrite R with something different. That's now the end of my if present code. I think I need a braces here. And now I say return R. Oh, because I was stupid, I forgot to take this out. Okay, now it doesn't parse. Yeah, at this point it would be nice to have a better IDE. Pair if present. Can someone help me out here? Where? Oh, I see. I'm forgetting a brace here. So now I'm getting to the error that I wanted you to experience. Now it says local variables referenced from a lambda expression must be final or effectively final. That is plain English for you're doomed. So what's happening here? Here I'm trying to modify R by assigning to it, and you're not allowed to do that in a lambda expression. You cannot change the values of any of the variables outside. So what can you do? So what could you possibly do in the code for if present? You aren't allowed to change any values. Let's look at our example before. Can this compile? It changed the value of results. This does actually compile. What's the difference? Why does results.add_v compile, but saying R equals v would not compile? What's that? They should be. So, in your extensive experience with inner classes, you must have run into this as well. It's no different. So in an inner class, you weren't able to do this either. You were never able to assign anything to a variable that came in from the outside. But it was perfectly okay to call a method on it, even if the method was a mutator method. So it's fine to call mutator methods. So that's your strategy here. So you're going to have some kind of object that you can mutate.
String buffer.
Excellent. Yes, except in nowadays one uses a string builder, which you can use a string buffer, but string builder is slightly more efficient. So use a string buffer or a string builder.
What's the difference?
A string buffer has all of its methods synchronized. And in that case, you need a return r.toString.